Hello, my name is Amy Rumora. I'm a postdoctoral fellow in Eva Feldman's lab at the University of Michigan. I study diabetic neuropathy, the most common complication of diabetes. People with neuropathy experience a loss of sensation in their limbs that starts in their toes and fingers and progresses upwards. Unfortunately, there's no treatment for diabetic neuropathy. While controlling sugar can slow neuropathy progression in patients with type 1 diabetes, it has limited effect in patients with type 2 diabetes. Studies from our lab have suggested that obesity and altered levels of lipids that are associated with neuropathy progression in type 2 diabetes may play a role in neuropathy progression. However, the specific metabolites that lead to neuropathy development and progression are unknown. Metabolites are a substance that are formed from metabolism of the food that you intake into your body. And since the metabolites that underlie neuropathy progression are unknown, we sought to study this using metabolomics. In order to do this, plasma from patients with type 2 diabetes without neuropathy, type 2 diabetes with neuropathy, and control healthy subjects were submitted for mass spectrometry and processed through a bioinformatic pipeline. These methods allowed us to identify specific metabolites that associate with neuropathy in patients with type 2 diabetes. Interestingly, we identified 993 metabolites in all three of these groups of patients. We found that diabetes had the greatest effect on changes in metabolites when you compare type 2 diabetes to the healthy controls, regardless of the presence of neuropathy. However, we were able to tease out 8 metabolites that were different between type 2 diabetic patients and type 2 diabetic patients with neuropathy. What's really interesting is that many of these 8 metabolites are related to lipid metabolism and mitochondrial metabolism. And the reason that this is so interesting is because the nerve is highly dependent on mitochondrial metabolism in order to generate energy for the survival of the cells in this tissue. So what we think is that the metabolites we have identified in this study in the plasma of patients with type 2 diabetes may be important for understanding the molecular mechanisms that underlie neuropathy progression in type 2 diabetes. We believe that lipid metabolism and mitochondrial metabolism may play an important role in the progression of neuropathy.